So this is 13.2, circles, tangents, and diameters on a coordinate plane. And by the end of this one, you should be able to look at some equations, or look at some circles and some points and some lines and derive the equations for those circles and points and lines. Or look at some equations and then draw the circles, points, and lines based upon those equations. All right, so let's get right down to it with an example. Okay, so this builds on stuff that you already know. So you're gonna have to dig into your toolbox and apply some stuff from way back when, maybe, and even some algebra from way back when. But we'll review some of that too, so don't worry. All right, so here we have a circle M centered at -2 and 1, and a tangent line with an equation y equals 2x minus 5. Okay, let's go ahead and highlight that with how about let's use orange as our tangent line. Okay, and then we have a center circle of blue. That's not blue. That's a blue one. Okay, our circle will be blue. Okay, and we got to write an equation, a line perpendicular to that tangent line. We're going to find a point that touches a tangent that touches circle M. We're going to call it R. And we got to find the radius and the equation. Well, you might remember that the equation for a circle is r squared equals some stuff squared plus some more stuff squared, and in this first one is x minus h and y minus k, where h and k are your center points. Recognizing that the negative value is the opposite of what your center point is. We have a center point of -2 and 1. Right, since this is -2, -2 turns our negative sign into a positive, so our equation is 2, and this is still, and our center is -1 for our y value, so it keeps the -1. Right, so we have almost everything for our equation to solve D, but we still need the radius. So once we figure out C, we'll solve D. All right, so we'll go ahead and just start with making a center at -2, 1. Right, so here's our coordinate plane. We're going to start at -2, -1, -2, and 0.1. Right, so that is our center of our circle right there. Okay, so now what do we know about our equation of our line, of our tangent line? Okay, so we have a tangent line equation that's y equals 2x minus 5. Well, let's dissect this again. Remember, it's our general equation equals y equals, that's supposed to be an x. Yeah, 2x. That's ugly. 2x minus 5. Y equals mx plus b, where this is our y value, our x is our x value, b is our y intercept, so where our line crosses the y-axis, and m is our slope, also our change in y divided by our change in x. Right, so we can figure out we can draw our line based upon this information. Okay, so let's do that. Right, let's start with your y-intercept. Your y-intercept is -5. So this line is going to cross the y-axis at -5. Right, so we go find our -5. We find y, 1, 2, 3, 4, 5. Y equals -5 is where this line is going to cross. And we also know that it has a slope of 2, which is also known as 2 over 1. Change in y, change in x. Right? So every 2, it changes and is going to change in x. And it's also positive, right? There's no negative sign here, so it's got to be positive. So the slope is going to go this way. It's going to go positive that way, right? So every 2 changes in y, 1, 2, there's a 1 change in x. And for every negative 2 changes in y, there's a negative change in x, because a negative divided by a negative is a positive. Okay? So I have 2 points that I can draw my line through. And I'm going to use a skinnier line with an orange pen. Where's my orange pen? There's my orange pen. Do my best to intersect these points of intersection like this. Stay on scale. Right, so that is my tangent line. That is my tangent line. My tangent line. Tangent line with an equation of 2x minus 5. Okay, so I got my line drawn there. Okay, so now the first question is write an equation, a line perpendicular to my tangent line. Well, what do I know about a line perpendicular to my tangent line? Okay, and I also want it, so what do I know about a tangent, right? I know 2 things about a tangent that are gonna help me, okay? One, yeah, I'll use this one, sure. My tangent line, my tangent intersects only at one point on the circumference. So that's one thing. So it's just gonna nick the side of the corner. And so 2, when it intersects my radius at a 90-degree angle, right? So that means, real quick drawing, and I have a line coming through here, intersects right there, and say this is my center, right? If I have a line coming this way, right, and this is my radius, or my diameter for that matter, this is a 90-degree angle. So it's got to pass through my center of my circle for it to be a radius, meaning that one of those points can be a point on my circle. Okay? So keep that in mind. And that it's going to be perpendicular. It's going to be perpendicular to my tangent line. Okay? So that's some important information. Okay? So here, let's look at that. All right, so if this is my tangent line, so if that is my tangent line, I need 2 things from it. Okay, did I flip on this one? Yeah, so my tangent line was y equals 2x minus 5. Okay, well, I need a line perpendicular to that. Okay, so to make a line perpendicular, I need a slope. I need to invert the slope, right? And I need to make it negative. All right, so to invert the slope, I'm just going to take this and turn it into 1/2 x. Okay, so that is my slope inverted, and I need to make it negative. Okay, so what else do I need to know? Well, I know that this has to intercept y at my center point, right? So when my y value is the center point's y value, y has to equal that center point value, right? So my center point was, what was my center point? Yeah, my center point was y equals 1, right? So when y equals 1, my center point, when y equals 1, at my center point, my slope had to be negative 1/2 x, and I don't want to shift that y-intercept at all, right? I'm just going to keep it at 0, right? So I can plot that, okay? I'm just going to go ahead and see if I can plot that line. All right, so go with my blue pen, and starting at 1, remember this is a change in y over a change in x, okay? So when y equals 1, my x value is going to be negative, so this is going to be negative, right? So it's going to be a negative slope, right? So I'm going to have a change in y of 1, and a change in x of 2, 1, 2, right? And it's going to be the same direction the other way. A change in y of 1 and a change in x of 2, 1, 2. Right there on the origin, look at that. Okay? All right, so now from there, I can plot this. I can plot my perpendicular line. So this is a line perpendicular to my tangent. Okay, so I've plotted a line perpendicular to my tangent. So I'll answer my question. My equation that works is do I want to solve this for x? Does the book have me solve it for x? No, it doesn't. Y equals negative 1/2 x. Was the way the book wants me to write that, So you could, that's the way that works, right? Plus 0 is the way if you want to do it, because the y-intercept is, look at that, is 0. All right, so that's that. All right, so so that's there. What's the next question here? Okay, find a point where the tangent touches circle M, and find this, and call this point circle R. Well, where would this point touch circle M? Well, it's going to touch here at this point right here, right? My origin might be a little bit different, right? But it's going to touch right pretty much there. Okay, so this point is going to be x equals 2 and y equals negative 1. Okay, it's a little bit off because my grid's not perfect. Right, but my x is going to be x equals 2 and y equals negative 1. X equals 2, y equals negative 1. This is going to be point R. Now, how would we do that with math here? Well, what we would do with math, how we would do that mathematically, is we're going to take our two lines that we solve for. We're going to take this line, our y equals this, and our line equals this. And we're going to say, hey, our two lines equal each other, right? And we're going to solve for that point, okay? So 2x minus 5 equals negative 1/2 over x, okay? And then we'll solve for our x value. All right, so I'm going to multiply both sides by 2, making this 4x minus 10 equals negative x. All right, so then I'm going to move this over to here, making this 5x equals 10, x equals 2. Okay, so if x equals 2, I'll just take x equals 2 and plug it back into this equation. So making that 10x minus 10 times, 2 times 2, excuse me. So this is going to be 2 times 2 minus 5 is going to be equal to negative 1. And then you see my x and y coordinates are going to be 2 comma negative 1, and there are my points 2 comma negative 1. Okay, so that is how you do that. Again, what you do is you take the lines for the 2, you take out the y, that's the transitive property, right? If y equals 2x minus 5 and 2x5 equals, and if negative 1/2 x equals y and y equals it equals 2x minus 5, then 2x minus 5 must equal negative 1/2 x. So you just set them equal to each other, solve for x, take that x value and plop it back in. Okay? So there is my proof there. So now I'm like, okay, well, what is the radius? Well, I have a line segment here, and I got to figure out the change in x and the change in y between them, between my radius and my point of intersection. Okay, so I'm going to make, need some more colors. I guess I'll use burgundy for my change in x. Change in x. Move it up a little bit so it highlights better. Okay, so my change in x is going to be this one. Oh, I went too far. Change in x is this one. That's my change in x. I did an eraser. There is this part. And my change in y. I think I have a pink one, right? I can use orange. No, I don't need green. There we go. I got a green one for change in y. And my change in y will be this one. Change in y, I can just count. It's 2. Change in y is 2. Change in x looks like it's 1, 2, 3, 4. 4. So I get together Pythagorean's theorem here. And it's going to be 4 squared plus 2 squared equals 20. Square root of 20 is going to be, let's do 20. Let's do this real quick. Let's see, square root of 20. I got a 4 and a 5. So I got a 2 and a 5. Right? So my square, my hypotenuse is 2 square root of 5. Yep, that's my hypotenuse, is 2 square root of 5. That is also the radius of my circle. So I go ahead and put it all together here. My radius of my circle is 2. It's going to be an ugly circle because of the ink in my blue pen. I have another blue pen. I should start using pencils. Oh man, it's running out of ink. Grading too many tests with it. Alright, there's my circle. This is 2 square root of 5, and that's my radius. So, answer my question, my radius is 2 square root of 5. So now I can finally complete my equation here. And my equation is 2 square root of 5 squared. I'm going to leave it like that. I want to. Equals x plus 2 squared. right? Because it's negative 2 plus y minus 1, because it's a positive 1, and that is the radius for my equation, or the center point for my equation. And that's my equation for the circle. Okay, so that is how that is all done. Hope that helps. Remember all those things.